Hi, welcome to this lesson on Euclidean geometry, polygons. Let's have a look at question 5. In the diagram, we have three equal circles of radius 3, units that are positioned such that they touch each other exactly at these singular points here. Now, BT is a common vertical tangent to these two smaller two equal circles on the left and the right. And CD is a common tangent that is horizontal to those same two circles. So there's a 90-degree angle here. Okay, they want us to show that the length of BT, so the full length of this line, is equal to 3 root 3 plus 6 units. Okay, so how do we go about doing that? So first of all, from the information, we're given that all three of these circles are equal. So they have the same radius. Okay, so if I put the centers of each of these circles in here, then what happens is, so I'm going to call this point, what letters haven't we used? So I'm going to say E, I'm going to call this F and this G. So E, F, G are the centers of those three circles respectively. So if I draw from this common point where they touch here, from E to that point, that is 3 units, and then from that point to F is 3 units as well. And then F to the endpoint there on that circle is also 3 units, because that is a circle and the radius is from the center F to that point there. Okay, so now this is a right angle triangle, because again, all right, this line is going to be parallel to that line, so by corresponding angles, that's also a 90-degree right angle triangle. So let's look at this triangle that we've constructed here. Okay, so from the center of the top circle E to the point F, let's give this point a name, let's call it S. Okay, so here we have a right angle, we have 3 units here, we have 3 and 3, so we have 6 units here in total. So therefore, by Pythagoras, right, from the Pythagorean theorem, we have that 3 squared plus the length ES squared equals 6 squared, right? So I can work out this length ES. So therefore, I have 9 plus ES squared equals 36. Therefore, if I subtract 9 on both sides, I have ES squared equals, so 36 minus 9, that'll give you, let's just check. So if it was 36 minus 10, it would be 26 plus 1, so 27. Okay, so 36 minus 9 is 27. So now, the length of ES is going to be the positive square root of 27, right? Because this is a length. It doesn't make sense for it to be negative. Okay, and I can simplify that because 27 is 9 times 3, so that's going to give me 3 root 3. So this entire length here is 3 root 3. Now that's very promising because there is a 3 root 3 that we want here. So hence, we can say that the length of BT must be from B to E, okay, then from E to S, and then from S to T. Now, BE, notice that this is also a radius length, so that's 3, plus ES was 3 root 3. Now, what is the length of ST? Notice that S is horizontally in line with the center of both circles. So therefore, this is going to be a square of side length 3 everywhere. So therefore, the length of ST is also 3. So 3 plus 3 is 6. So I have 3 root 3 plus 6. And that's exactly what we wanted to show what BT was equal to. So in this question, we had to recognize the common points where the circles touched each other. We had to notice that we could form a right angle triangle. And then from there, construct the length of BT by breaking it up into these 3 components here. Okay, so that's how we would do this type of question. I'll see you in the next one.